Okay, 6.2 is related with the nuclear energy. Okay, the nuclear energy means after the decay, they produce large amount of energy. So this one energy, we need to know how to do the calculation, total energy, how they produce. Okay, so the first one, we're going to see the nuclear energy. Okay, nuclear energy is the atomic energy. So the atomic energy means the release from the decay, alpha, beta, gamma decay. They produce the energy, so we call atomic energy. Released during the nuclear reaction, such as a radioactive decay. Okay, radioactive decay. Then after that, we got nuclear fission and nuclear fusion. So from this topic, we need to know is a two of the nuclear process. Nuclear energy, first one they can produce from the nuclear fission. This one's the first process. Okay, second process is a nuclear fusion. You can see what's the difference is a spelling only. Okay, later we see the process. Important, you need to know the spelling must be correct. Fission, another one is a fusion. This one is a two process radioactive decay. After that, they produce large amount of energy. Okay, now we're going to see one by one what's the differences between the fission and also the fusion. Okay, so nuclear reaction, they separate by two of the different of the process. One is a nuclear fission, another one is a nuclear fusion. Okay, both also produce a nuclear energy. Okay, so this one we introduce to nuclear activity first. Okay, both also will loss of the mass. So after decay, they sure will lost the mass. So lost the mass, we call it mass defect. Okay, so this one is the meaning of the mass defect lah. So that means before the decay, the mass sure is higher. After decay, sure they lost the mass. Okay, lost the mass go where? They generate the energy. So they lost, maybe they come out the new daughter. After new daughter, after that they got energy to produce. So the new daughter become lighter already. Then that means the energy lost. Lost go where? Become nuclear energy. Okay, so this one we call mass defect. Okay, nuclear fission. We're going to see the nuclear fission first. Okay, we're going to see this one video explain first. Okay, see the diagram, uranium. Normally we're using uranium because there's an unstable nucleus. Okay, fission, you can see the split become smaller. When starting bigger, after that the split 2 or 3 smaller of the daughter. Then after that, we got chain reactions are more. So this is a short video. Later, I explain for you. Okay, first one, we see the word fission. Okay, definition is this one. Nuclear fission is a nuclear reaction when heavy nucleus. Remember, start with the heavy nucleus. This one, heavy nucleus, sure is an unstable one. Okay, after that, the split. Okay, split means the separate. 2 or more lighter nuclei. Okay, that means more than one. Then they separate 2 or 3 lighter one. That means just now it's a heavy. That means they separate the daughter, become lighter one. 2 or 3 daughter. After that, they will release large amount of energy. So this is a definition for nuclear fission. So from the bigger size, they split to smaller size. Okay, or 3. Okay, we do know the situation. After that, plus large amount of energy. So this one is a process for the nuclear fission. So from here, I do want you to bullet to memorize the word. So you can from the diagram. First one, you say this one is a heavy nucleus. After that, split to the 3 or 2 lighter nuclei and also produce large amount of energy. So refer the diagram, then we create the sentence. So this one is a nuclear fission. Okay, then we go to the next one. Okay, this one is the real diagram for the nuclear fission. So you can see the first one, unstable nucleus, uranium. Okay, they must have the 1 neutron go to hit the uranium. After that, the uranium will split. Okay, now you see this one diagram, the split become 2 lighter nuclei. Okay, what they produce, we no need to memorize. They produce PA lah, they produce KR lah. The one we no need to memorize. We just need to know they produce is a 2 or 3 lighter nuclei. That's all. After that, must remember 3 neutrons and produce 3 neutrons. So that means when starting, we got 1 neutron go to hit unstable nucleus. There's a uranium. After that, uranium will split 2 or 3 nuclei and also 3 of the neutron. Don't forget plus energy. So this one is a process of the nuclear fissions. Okay?
Sure.
Yes?
The 3 neutron is fixed one.
3 or 2, something like this lah.
Or not
Neutron.
all the atoms fission will produce 3 neutron. Some will produce 2 also.
Yeah, so sometimes you say 2 or 3 neutron, sure we produce a neutron. Because this one neutron later, they will find another uranium unstable and do again. So the process will be repeated. So you see when starting is a 1 neutron, hit 1 uranium. So they produce a neutron, also will find the uranium and hit again. So that means the nuclear fission process will be continuous. Okay, if not neutron, that means we cannot happen for the nuclear fission. Must have the neutron go to hit the uranium. Okay, so we're going to see a uranium-235. Okay, we never say hit. We're using the word is a bombarded. They go to bomb. So the uranium-235 nucleus is bombarded by the neutron. Okay, after bombarded, you see an unstable uranium-236, they will produce. Produce what? Okay, produce 2 lighter nuclei, a barium, okay, and also the krypton nucleus, and also 3 neutrons are produced. So they explain for you the 2 lighter nuclei, one is a barium, another one is a krypton, then plus 3 of the neutrons are produced. And also don't forget, energy also released. So this one is a whole process of the nuclear fissions. Okay, so we're using the word bombarded. Uranium will go to bombarded with the unstable nucleus. There's a uranium. Then the unstable uranium nucleus produced, then they separate by 2 lighter nuclei. Okay, you no need to mention what's the name because we also do know. Sometimes they come out another one. So it's just 2 lighter nuclei and also 3 neutrons plus large amount of energy. That's all. Okay, so this one is a formula. So the formula never asks you BA, what is the neutron number, what is the proton number. No, they either call you to fill in the number only. Maybe 141, they blank. They call you to fill in. So this one is an equation for the nuclear fission. So how to know fission or fusion? Fission must have one is unstable. Unstable, how I know? When you find the neutron number is very large. So that one is unstable. Then sure they will plus 1 neutron. So this one we call unstable. This one we call nuclear fissions. After that, you can see uranium. After that, they will bomb. Bomb after that, they come out 2 lighter nuclei. The 2 lighter are, we don't know what name. They're just the proton number, the neutron number will be less lah. Then after that, how many neutron? 3 neutron. So that means you plus the neutron number, plus the neutron number, they will same like the original. So original is how many? 235 plus 1. Then equal 141 plus 92 plus how many? In the question we ask you this one. They never give you the 3, they put X. Then I ask you X is what reading? What's the number? So you see this one is a 1, is it? So you're going to find X is how many? So after that, you find the X is 3, then you put in. Then after that, you do the calculation, it's a tally one. The total will become 236. Okay, so the question normally come out like this. They never call you to write the whole equation. Okay, either they call you to explain what is a nuclear fission, or they want you to complete the equation. Okay, so this one is a question will come out like this lah. Okay, now we're going to see fusion. What's the difference of fission and fusion? Okay, you can see the fusion. 2 lighter. You can see this one 2 only, this one 3. Tritium and deuterium. After that, they combine. They will combine. Combine already become the bigger one. Become the helium already. Okay, after that produce energy and also the neutron. So the differences fission and fusion is fission is a big size. Then they want to produce 2 lighter daughter. Okay, then the fusion is different. Fusion is I am lighter. I got two lighter nucleus. After that, I want to combine. I combine become heavier nucleus. So this one is the differences. Okay, now we're going to see explanation for the fusion. Nuclear fusion is a nuclear reaction from, they want to form the heavy nucleus while releasing the large of energy. Just now it's split. This one they want to form. That means they want to combine. Okay, when they just combine, they also produce the large of energy. Then after that, they come out one of the neutron. So this one nuclear reaction happen only under extremely high temperature and pressure. So that means not simply to happen. You never say, oh, I burn, then can happen already. No, this one need to high temperature and also must be high pressure. So normally the power station, we never using nuclear fusion because nuclear fusion sometimes they need the sun energy, solar. Okay, so the power station normally we're using is a nuclear fission because we can control. We can control the heat, we can control the uranium. So that one is a power station. So fusion we seldom to use, but this one normally they're using for the solar energy lah. But in the produce a high energy, a high temperature and also pressure. So important, differentiate the pattern of the fission and also the fusion. Okay, fusion also got formula. Okay, let's see the formula for the fusion. Okay, now you can see the nuclear fusion. You can see first one, deuterium, then tritium. Okay, deuterium is a 2. Okay, this one is a 3. Okay, after that they combine. After fusion, join together. After that they combine. Combine become one heavier helium nucleus. So they produce helium. So that means they will join become, after that become one heavier nucleus produced. After that, remember, they will release one neutron and also large amount of energy. So this one's the differences, fission and also the fusion. Okay, let's see the equation. So you can see the equation is a lighter one. Helium, the deuterium and also tritium. Then they join. After they become one heavy nucleus, there's a helium. Then plus one of neutron and also the energy. So you see the formula, then you know already which one is a fission, which one is a fusion. Okay, understand, huh? Fission and also fusion. Okay, now you see atomic mass unit. Okay, atomic mass unit, this one is a unit. They want to measure the mass of particle. Okay, radioactive particle, alpha, beta, and also gamma. Because the mass is too lighter already. If you're using kg, there's a negative 28, 29, too small already. So they're using the AMU, stand for the unit. Normally, we don't write MU, we just write U only. Then we understood. Okay, there's an atomic mass unit. Okay, atomic mass unit, AMU, is a special one unit they use to measure the mass of the atom. Okay, because too small already. And subatom of the particle, example, proton, neutron, and electron. Okay, because the mass is too small. So they change another unit to measure. There's an AMU. Okay, now AMU means what? AMU unit is stand for 1U. We write 1U. We never write AMU too long already. There's a 1/12 of the mass of the carbon. And they use the carbon as a standard. So that means AMU, 1 AMU actually is how many? There's a 1/12. That means 12 times smaller than the mass of the carbon. That one is stand for the AMU. Okay, 1 AMU. So suppose is how many? The mass of the one carbon like this. This one is a carbon one. So you are 1/12. That means this one you need to divide by the 12 lah. So we find it. Okay, after divide by the 12, the answer is 1.66 times 10 power negative 27. This one is a fixed, constant one. So 1U you want to convert become kg, you need to multiply this one value. Okay, this one is normally the question formula they were provided. Okay, because we no need to memorize one. 1U, there's a how many become the kg. Okay, but you need to know how many smaller from the carbon. There's a 12 times smaller than the carbon atom. Okay, so from here, I show you the MU. Sure, you need to do the calculation for the energy. Okay, let's see one. In a nuclear reaction or radiative decay, total mass Total mass of the decay products is always less than the total mass of the radioactive nucleus. So that means radioactive is before. This one is a before. After you do the decay products, sure is a after, you sure become less. Less mass. Because your mass already changes become the energy. So from here, we can say the loss of the mass, another name they call is mass defect. Okay, so you can fill in the blank from your notes, because some is empty space for you to fill in the blank for the explanations. Okay, when I explain, some is the spaces for empty one, that means you can fill in. So this one mass defect, I think already inside your notes, that's the number 6. Okay, so that means before sure the mass is the highest, after decay, the mass become less. This one mass become less, we call it as a mass defect. Then the question will ask, why the mass become less? Because the mass already convert become the nuclear energy. Okay, they lost by the energy. Okay, so from here, this one is an example for nuclear fission. You see the neutron go to bombard the uranium. After that, they produce 2 lighter state nucleus, daughter nucleus. After that, there's a Kr and also barium and krypton. After that, 3 neutron. Okay, don't forget energy. So that means after they produce this one we call after lah. The energy when you total mass sure less. This one total mass must higher a bit compared to the final. Because you got energy. So if I plus together, suppose it's equal lah. So the question never call you to plus together. They just ask you why total mass will less. Because some go energy already. Okay, so this one is a mass defect. Okay, this one before, this one is after. So from here you can see the example, total mass before the fission. The number, how many, actually you don't need to memorize. The question is provided. You can see 235 neutron number, is it? But actually it's a so bigger, 235.04392, is it? So they're just using the short one, 235. Then proton number 92, suppose it's got so many decimal point behind lah. They're just using the in front one. Okay, but when the question provided the number like this, you don't cut lah. You don't say, oh, I'm using 235 only. Cannot. We must using full. Okay, they give you how many decimal point, you also need to copy until the end. So from here, this one before fission. So I plus together, I get 236 point. This all thing you need to write. You don't cancel, don't round number. So you need to write 05259, then this one AMU. Okay, still the unit for AMU. Okay, then I continue for total mass after the fissions. So I plus all lah. This one is krypton. This one is a barium. Barium is here. So I got 3 neutron. 3. So need to time 3. Okay, so after that I find it. This one is my after decay. The total mass is how many? So I go to minus lah. I'm going to check what is the mass defect. Okay, the mass defect after I minus, this one is the final mass defect. But normally the question, they want you to convert become kilograms. So you need to convert become kilograms. Okay, so this one is how to do the calculation. Only plus and minus, I think no problem. The problem is the number too long. So when you press the calculator, must be careful.
So all the mass defect is the energy lah.
The mass defect, we never call it energy. We just only say there's a mass. After that, when do the energy, we need to do the calculations. That means the energy is related with the mass.
Okay.
Okay, now we're going to see the energy, how to do the calculation for nuclear energy. So both nuclear fission and also fusion, they also release large amount of energy. Okay, the source of this one energy from loss of the mass in the nuclear reaction. So they tell you the source for this one energies come from where? Come from the loss of the mass of the nuclear reaction. So that means come from the mass defect lah. Just now we find it. So if the mass defect is a high, That means your nuclear energy also must be increased, directly proportional one. So the sum of the masses of the particle before the reaction is more than the after the reaction. So they tell you before sure is more than the after decay reactions. So from here we go to introduce mass defect. We can say there's a mass loss. Okay, mass before minus the mass reaction. So this one is a formula how to find the mass defect. Okay, the relationship between the mass and energy directly proportional. So they create the formula from the Einstein, E equal mc square. Okay, E is a nuclear energy, M is a mass defect. So the problem is the question normally they want to find energy. Then the question give you all the number. They never give you mass defect. You need to find the mass defect by yourself. Baru you can find the energy. So the problem many students they make the mistake is a mass defect because the number too long already. When they plus minus, they less one number, that means the whole calculation is wrong. So you must be careful. Then the last one, c square, everybody knows speed of the light, 3 times 10 power of 8. Then remember, go to square. Many students also forget go to square. So this one we call energy, nuclear energy. The last one, energy, we need to know for our syllabus. That's from the Einstein, E equal mc square, nuclear energy. Okay, so only one of the formula for this topic. So remember the formula. Okay, one more, you need to know energy always, unit joule. Okay, don't care what energy. When you just mention energy, the unit must be joule. Okay, we're going to see one example. See, okay, the equation before show about the radium is 226, decaying into the random 222 by emitting the alpha particle. Okay, now giving, let's see, the question giving all in for one. You see, Ra, AMU, Rn. Then after that, helium. Calculate the nuclear energy. So the question they never call mass defect. You need to find by yourself. Last one, they only need energy. So you need to do the mass defect first. Okay, after you do the mass defect, I suggest you don't change to kilogram first. Do the AMU first. Final, you get the final answer for AMU, then you baru change to kg. Then after that, you go to apply E equal mc square. Okay, so from here, you need to write full. So that means support is a 226.54 minus Rn 222.018 plus helium 4.003. After, you get how many AMU? This one is what you want to get it. Okay, so from here I get it, the answer is, because that's straightforward, go to multiply. Okay, you go to multiply, you get the answer first. After that, you go to change. Multiply 1.66 times 10 power negative 27. Okay, then you get the mass defect. Okay, kg. Okay, please do now. Then after that, we're going to check the answer. Okay, so is it this one is a 0.519?
Yes.
Okay, so you go to multiply this one. Finally, you get 8.6154. Is it? Times 10 power of negative 28. Okay, I'm going to show. Okay, I get 0.519 AMU. Convert to kilograms. Okay, 8.6154 times 10 power negative 28. Okay, I find the mass defect already. So finally, I want to find the energy. So I apply E equal mc square. Like this, no problem already because you get the mass. Mass just put in, then the C using this one. Remember square. When you press your calculator, you press wrong, is it? Don't together. You press this one 3 times 10 power 8 square first. Baru you go to multiply this number. Okay, don't together, then equal. Maybe the calculator is no clever like this. So better we separate and press your calculator. Okay, now we're going to see E equal mc square. Okay, better you press this one first. Press this one first, or you put the bracket, up to you. So when you square already, baru you go to multiply your mass defect. So this one is the final answer, 7.75 times 10 power negative 11 joule. Okay, I can tell you only the final energy, you can write 2 decimal point. Minimum, if you 6 decimal point, up to you lah. So minimum, we no need to write the full when you find the energy. But the mass in front, all the mass cannot, don't cut. Only the final answer for energy, you can cut 2 decimal point. Okay, the rest, no, must using the full in full. Okay, the sun is the source of energy, and when you see sun, understood that one is a nuclear fusion already, because solar energy one. This energy is produced by the nuclear fusion in the core of the sun. Okay, they show you the equation. So the equation, you can see the lighter one join become the biggest one. So they want to calculate the nuclear energy released in joule. Okay, they give you AMU, they give you speed of the light. So the info they provided, this one. So mass, okay, this one is a 2. So your paper, I think there's a 1, is it? I mean to change. Your paper, they show 4.1, I think so. You have me to change become 4.2. There's a helium. Okay, helium, and this one is a neutron. Okay, this one is an info, the sure we give you one. Because we no need to memorize the mass is how many. Okay, so from here also same lah. Find the mass defect first. So that means you need to using this one. The first one, deuterium, go to plus the tritium. Then you go to minus the helium and 1 neutron. Then you find the mass defect is how many. Okay, so from here, if for me do the calculation, I get it 5.030 minus 5.012. So I get it 0.018 AMU. Okay, this one is the answer. I get it. You check, is it you can get this one or not? Okay, you can press your calculator straightforward, go to minus. Okay, when I just convert mass defect, that will become 2.988 times 10 power of negative 29 kg. If I convert AMU, become kilograms. So the calculation like this, 2.014 plus 3.016 minus the helium and also 1 neutron. Okay, after that I get it 0.018 AMU. Okay, convert the AMU, become the kilograms. So this one should be the answer. Okay, after that I need to using the mass defect to do the calculation for energy. E equal mc square. Okay, so from here E equal mc square, I just apply. Okay, take the just now the mass defect, multiply the c, speed of the light square. Then after that I get this one final answer. Okay, E equal mc square 2.69 times 10 power of negative 12 joule. Okay, so this one is the final answer. You can see, suppose the E, you can see the E suppose was so many behind like the decimal point, but energy, I can make it become short. I can make it become 2 decimal point. But when you do the calculation for the mass, cannot. We need to using the full one. Okay, then we go through for the example 3. Okay, example 3, during a nuclear fission. The word already show you. Fission. A sample of uranium experience a mass defect. This one question better because they show you the mass defect. So you no need to do so many calculations. Okay, then they ask you what's the amount of energy released during the reaction. So we can straightforward using E equal mc square. Okay. Okay, so from here you can see this part, E equal mc square, we need to find is a E. So we just apply E equal mc square. Then the mass defect we just copy from the question, then multiply the speed of the light square. Okay, then the final answer, what's the answer, Celia?
1.548 times 10 power negative 3.
Then?
Joule.
Joule. Okay, so this is the final answer for this question. This one question quite simple lah, because they show you all the mass defect, so you don't need to do one by one. But normally the question want you to do one. Okay, they need you to do the calculations. Okay, then we go through the next part. Next part, example 4 and also the example 5 you need to do by yourself. Okay, I can show it later. Later we discuss like got time. Okay, we're going to see the nuclear power station first. Okay, this is one of the process. For the power station, they're using the nuclear fission, okay, to generate the electricity. So step by step. So what I label 1, 2, 3, 4, that means it's a step lah. So we go through the step. Okay, if I'm not forgotten, you can see the notes. They got want you to fill in the blank. Okay, they got one part. They want you to fill in the blank for the how the nuclear fission, nuclear power station to function. You go to check. Is it got? Okay, so from here you see the step number 1 until number 5. So we go to two part first, because nuclear power station can separate by two part. One part we call nuclear reactor. Nuclear reactor means they do the nuclear fission. And the second part we call generator. Generator means they want to generate electricity. So we go through the first part. Okay, first part is a nuclear fission happen. Nuclear fission will happen at the part 1. Okay, part 1, nuclear fission happen for the uranium. They're using the uranium. And also chain reaction produce the heat energy. Okay, later I will explain what means of chain reaction. Chain reaction means the parents become the daughter already, is it? Chain reaction is repeated. That means just now you don't forget the uranium neutron bombarded, produce 2 lighter nuclei, and also 3 neutron. This one, 3 neutron, we go to find uranium again. Then again. So you can see the pattern. Then this one 3 neutron again. This one 3, 9 neutron already. This one 9 neutron will continue to find the uranium. So you can see this one we call chain reaction. The process will continuous to happen. So that means how about the energy? The energy should be very high lah. So for this one situation, so the nuclear fission for the power station, they're using chain reaction. That means there's a non-stop, continue to do the nuclear fission. So the first part, chain reaction will produce a heat energy. So from here, you can see the heat energy we produce for this part 1. Okay, so this one water sure is a very hot. Okay, follow the loop. Okay, the hot water. So from here, you can see number 2. Number 2 is this part. Okay, the water is pumped into the reactor core to absorb the heat. So you produce the gases. This one is steam. The steam you produce for this one, the whole tube. So this one loop. This one loop by the shape one. Okay, this one loop inside is a water. So now you got steam. The steam is a hot steam. So this one hot steam, you make this one water inside the loop become hot. Okay, so they say water is a pump into the reactor core to absorb the heat energy that is produced by the nuclear fission. So when starting the water at the bottom, maybe they cool a bit because you produce the gas, so the water become hot already lah. Okay, because the heat produced from the nuclear fission. So if the water become heat, they become steam. Okay, then after that, they're boiling, they produce the steam, go where? Go up until the steam flow. Okay, part 3 is a steam to flow. So that means you need to explain how come got steam. Okay, because of the hot gases. The hot gases come here, they go to heat the water, then the water heat up, they produce more steam, then the steam will go through to the heat, the steam flow. That's a part 3. So part 3, you go to explain. The boiling of the water produce high pressure steam. That means the steam not only hot, they also high pressure. So this one steam will be channeled to the turbine. They go number 4. After the high pressure steam, they go to part 4. And the part 4, they want to turn the turbine. So they're not using the hand to turn the turbine. They're using the hot heat steam. The steam is a hot and also high pressure. Then until they turn the turbine. Okay, some students will say, if the steam is not success to turn the turbine, Where they go? Okay, example, you can see the steam flow until go to turn the turbine. So sure got extra one, not all will go to turn the turbine. Extra one will go condenser, become water again, come in this part. Okay, come in for this part. This one was one of the tank water pump again. So that means this one is a process until number 4, they will repeat it. Okay, they will repeat it. So this one also got, you see number 3, the steam go through the steam flow, is it? Some of the steam cannot go to steam flow, go where? Go down again, no? Go down again and redo the nuclear fission. Okay, the steam success, they go through the steam flow to turn the turbine. Okay, the steam go to turn the turbine. Also, not all the steam can turn the turbine. Some release, they go down, become condenser, become water again, and repeat here. So that means number 3 you can repeat. Then number 4 you also got repeated because the steam not all using. Sometimes the steam lost already, then it come down. So this one is how to start to produce the steam. After that, go turn the turbine. So this one is a part for nuclear reactor. Okay, start with the fission. Then the fission, after that, they produce large amount of energy. Then got hot gases. Then the hot gases will go through to heat the water. Then the water also got steam up. Now you can produce more steam. Now the steam will go to the steam flow. Okay, the steam flow, that means the steam is high pressure. They turn the turbine. Okay, some of the steam cannot turn the turbine, then it turn back, condensation become the water, and repeat again the process. So this one is a nuclear reactor part. Okay, start after 4. After 4, we got generator part. Okay, now we're going to see, this one is just now I mentioned. Okay, example, you can see the part. Okay, cathode ray, this one is a nuclear fission. Then after that, they're going to turn the turbine, the steam. You can the steam so hot. Okay, if cannot, then they come back lah. Then become water again, then repeat. So this one is a diagram for the generator part, for the nuclear reactor part. Okay, then we're going to see number 4. After they turn the turbine, what happened? Okay, turbine is rotated by the high pressure steam, which is rotate the magnet and coil. Remember, you want to turn the turbine, they generate electricity, we must have the magnet and also the coil. So for this one is you need to generate the electricity, so they must have the turbine. Then the turbine design must have the magnet and also the coil. Okay, coil means the wire turning. Then the magnet and wire turning is together. After that, they generate electricity, just like your dynamo. Example, the dynamo for your bicycle. Okay, they must have the coil magnet and also the wire together. When you just start your bicycle to turn the wheel, that means they make the magnet to rotate. After that, they produce the electricity. The concept is like this. So that means the turbine also got coil and also magnet. Important is how to make it turning. So we're using the steam, high pressure steam to make it become rotate. So after that, they generate the electricity. Okay, so that means the steam also, the extra one, the steam, they say the condensation again become water. So that means part 4, there can be 2 ways. They generate to turn the turbine. They also extra one will go down, become water again, then redo the process. So number 5, sure, is the electric energy generated is sent to consume wheel to the power supply transmission system. So this one is a process you need to know for power station. Okay, so you can see some of the short video. Nuclear reactor, okay, turn. Then the water extra, they repeat for the nuclear reactor. Okay, the heat exchanger, then they go to turn the turbine. Okay, this one is a part extra. So you can see the high pressure steam, they go to turn the turbine. Extra one go where? Go down, condensation again. So this one is a loop, okay, water loop. So some is become the hot steam, they go here. Extra one, come back again, redo. So we got 2 parts, is a redo one. Part 1, part 2 to redo. Okay, success one, you straightforward to go, then you can generate electricity. Okay, so this one is a 2 part, there's a redo part. Okay, then we go through to the next. Okay, chain reaction. Just now I said I want to mention about chain reaction, is it? Chain reaction is this neutron is bombarded another uranium nucleus. So that means they only do first time, then you produce 3 of the neutron. This one neutron will find the new uranium, then bombarded again. So the more fission will be occur, then they release more neutrons some more. So the chain reaction will be produced. So that means in the power station, the happen nuclear fission is a chain reactions. So these all things we need to control, because if you cannot control, the chain reaction will happen very fast, and also the energy also very fast to produce. You cannot control, that means they will become the bomb, power bomb. Okay, nuclear bomb. We can control, that means we can generate electricity lah. If cannot control, they will become one of the dangerous thing. So the uranium atom, they will combine, continue to spread, significant amount of energy is released. So the heat release is harmless and also used to generate the electricity. So you can see control one, we can say power station. That's a good, can produce a power station, can generate more electricity. If cannot control, they become nuclear bomb. That's one of the thing why Malaysia want to use the nuclear energy for this one power station. Okay, that's just very, very dangerous. But the advantages, sure, the energy is more compared for the hydroelectricity. Okay, they can produce more of the energy for 1 times. Okay, but this one we need to know the secure lah, how to do the procedure, go to juggle these all things. Okay, so this one is a diagram from the chain reaction. First round, you can see this one is a fission. No? Okay, now they're continuous to do. Okay, they produce 2 more, then 3 neutrons are more. This one can be continued again. So that means the chain reaction will be continuous and produce large amount of energy. Okay, so this one we call chain reactions. Okay, control of the rate safety feeders for the nucleus reaction. Okay, so this one I'm going to explain this part. This one, just now I tell you. Okay, every part you need to know what's the functions. Okay, this one is the nuclear reactor. First one, we see the control the rate. Okay, how we go to control the rate of the nuclear reaction. Okay, first one we got control rod. Control rod is this part, the dark color one, control rod. Okay, control rod is the reaction rate by absorb the excessive neutron. Okay, this one control rod normally using boron. Okay, for your note, they've got write the boron control rod. Okay, function, they want to absorb. Straightforward, they go to absorb the neutron. When they absorb the neutron, that means you only got uranium. Cannot happen the nuclear fission. So the function, they want to reduce. Okay, they want to slow down the process of the nuclear fission. So they go to absorb the neutron. Okay, they make by boron. They also can make by cadmium. So this one is the function for the control rod. Normally the question will ask what's the function for control rod? So from here you must say reduce the rate of the nuclear fission. Okay, make the nuclear fission become less because they absorb the neutron. Okay, moderator, another name we can call it, there's a graphite. This one is a graphite. Graphite, graphite core. Okay, slow down. This one different with the boron. Boron is totally absorbed. This one only slow down. Slow down, still got fission happen, but slow only. Okay, but controller is totally going to absorb the neutron. So the rate of nuclear fission can be less. This one only slow down. So to slow down the fast moving neutron release so that the nuclear fission can occur. So make from the such as a graphite or water. So this one is a different control rod, and also graphite core is a different. One is totally going to absorb. If they absorb, they can reduce the rate of nuclear fission. Slow down, that means the nuclear fission still got, but you can make it become slow. The process still go, but slow only. Okay, so this one is a different graphite and also boron. Okay, safety one. Let's see for the safety. We got thick concrete wall. The wall must be thick. Why? They want to prevent the leakage. Okay, when they do the nuclear fission, they produce so many alpha, beta, gamma, is it? They just want let this all radiation prevent to leakage to the surroundings. So they're using the thick wall. Okay, after that we got cooling agent. Water has the cooling agent. Okay, absorb the heat energy lah, because this whole thing is a high heat. So while you put the water, we absorb the heat from the chain reaction to generate the steam. So this can control the reactor temperature. So water is a high specific heat capacity. They can absorb more heat. So we're just using the water to reduce the heat for the whole nuclear fission process. Okay? Hello? Are you still here?
Okay, okay.
Okay, and then we need to go is another part. Okay, I know another part. Another part you refer your notes. Another part is a generate electricity already. Okay, the steam generator, the turbine, the coil, and magnet. That one is how we go to function. Okay, now I want to see the tutorial. Okay, I think this one question is not in your notes. So we do together. Okay, let's see the question. In a nuclear reaction, two deuterium atoms are fused to form. Okay, two deuterium. You tell me fission or fusion? Fission.
Fusion.
Fusion, because deuterium is a H2 one. The one is a fusion. Okay. Then after that, they form the equation. They show you equation already. So we know this one is a fusion. Okay, after that, they give you info, the masses of the deuterium and also helium, tritium. So from here, we continue to show the question. Okay, the information on the particle involved in this one equation they show you. Name the type of the nuclear reaction. Okay, just now we answered already. There's a nuclear fusion. So the question normally the simple when starting they ask like this lah. They ask you this one is what energy, what nuclear process. Okay, number 2. Determine the mass defect in kilogram after these reactions. Okay, so you need to find for me what is the mass defect for this one process. So you just times 2 lah. For the deuterium, they got 2, is it? You times 2. After that, you go to minus this one. Okay, so from here, determine the mass defect. So you find the answer is how many? 2 times 2.015. Okay, then do minus 3.017 plus 1 neutron. After that, I get the answer is 4 times 10 power negative 3 AMU. Okay? Is it perfect? Is a 4? You got any decimal point?
No decimal.
Okay, so we convert become kilograms because they want in kilograms. So I multiply the 1.66 times 10 power negative 27. So I get 6.64 times 10 power negative 30 kilograms. Okay, I think this one no problem. Then the next question, sure they want to find energy lah, if I'm not mistaken. Let's see. Okay, calculate the nuclear energy lah. So the pattern you can see almost like this only. We cannot do anything. Okay, so from here we just apply E equal mc squared. Okay, so after that you take the 6.64 times 10 power negative 30, multiply the 3 times 10 power 8, remember square. Okay, after that the final answer in joule. Okay, 5.976 times 10 power negative 13 joule. Then we go to second question. Okay, now reactor. Okay, these are fission or fusion?
Fission.
Fission, because you see the uranium, biggest one, then the split becomes smallest. Okay, so this one info. This one is an info that give you all the masses. Okay, they give you AMU, they give you speed of light. Okay, name the nuclear reaction. There's fissions. Okay, then we continue. Determine the mass defect in kilogram after the reaction. So we need to do is a neutron plus uranium. After that, you go to minus the SB, minus the MB. Don't forget 4 neutron. Must see, be careful the equation. We got 4 neutron. Okay, so that means you need to do the calculation now. Okay, 4 neutron is a special one. Don't ignore the 4. So you take the 1.009 plus the uranium 235.0439. Okay. After that, you go to minus. Okay, minus the bracket is SB 132.9153 plus 98.9116 bracket. Then you bracket again plus 4 times 1.009. And then you put the big bracket. Then you go to minus this all thing lah. Okay. So final answer, what you get it?
The AMU is 0.19.
Okay. So we go to convert kilograms. 3.154 times 10 power negative 28 kilograms. Right? Right or not? Siliang?
Yes, correct.
Okay, so become mass defects. So the next one show energy lah. So we go to check for the energy. So the question give you the speed of light, all the things. So calculate the nuclear energy. You can see special one. Mega. Okay. Mega electron volt. So from here, we're going to see how to change. Okay. This one is an info. Nuclear energy can also be expressed in the unit mega electron volt. So mega electron volt, 1 mega electron volt represent 1.6 times 10 negative 13 joule. So that means you find in the joule first. After that, you go to convert. Okay, so I go to find the joule first. Okay, mass defect, then I'm using E equal mc square. Then I go to find in joule. So my answer in joule, 2.8386 times 10 power negative 11. This one in joule. So I want you to convert become MeV, mega electron volt. So I need to divide lah. Divide 1.6 times 10 power negative 13. So I can become MeV. So I just go to divide. Get 2.8383, x6 is it? 6, so that's wrong already. Okay, 6 times 10 power negative 11, then you're over 1.6 times 10 power negative 13. Okay, I don't know my answer got wrong or not because this one I'm typing wrong already. So you check your final answer is how many? Okay, 2.8386 divide by 1.6 power negative 13. Okay, 1.7741. Okay, 1.774125.
177.4125.
Wait mega. Yeah, okay, 1 point is it?
177 177.4125.
Okay, if you go to this one, wait if I go to do just now 3x6 divide by, you get how many? Negative 11, then over 1.6 power negative 13. So correct lah. This one answer is it?
Yeah.
Okay, 177.4125. Then don't forget the unit become mega electron volt. So you bring the unit come here. So this was one of the extra things. So they want you to convert, they sure need to give you this one. Okay, we also no need to memorize one. We also do know how many. Okay, so this one is one extra thing you need to know. Although they until joule already, they also can call you to convert the unit. Okay, become mega electron volt. Okay, so this one example 2. So you can see the example 3. Okay. So this one, they give you simple of the formula. Okay. This one is not related with the fission and fusion. This one just only the alpha decay. Produce helium. Okay. So from here we continue. Calculate the nuclear energy released in joule. Okay. So must have the info lah. Nuclear energy released in the joule. So from here, okay, now you can see later I share you already one of the Google form. Okay, got code. I give you the code earlier first, not finish. The code is quite long. So later you go to fill in the Google form, you need to fill in the code. So the code, when starting, hashtag, the symbol for the hashtag, energy, no spacing, hashtag energy. Energy is a capital letter, ENERGY. Okay, so this one is the first. Later I will continue to give you. So from here, this one is the info they give you. They want you to calculate the nuclear energy released in joule. So from here must have the mass lah. If not, cannot do the calculation. So from here, the thorium, radium, and also helium. So you take the first one, go to minus the rest. Find the mass defect first. So we get it, the mass defect like this. Okay? Write all the number, don't cut lah. Okay, after that, I find it, the AMU become like this. 5.897 times 10 negative 3 AMU. So I need to convert AMU, become kilograms. So I get it, 9.78902. You see, I write 4. I never cut. I write the full one. Okay, the mass defect is 9.78902 times 10 power negative 30. Okay, so after that, you convert, become energy. The question sure will ask you the energy, nuclear energy already. So you just take the mass defect, multiply the C square. Okay, so you can get the answer in joule. Okay, what's the answer in joule?
8.81 times 10 power negative 13.
Okay, 8.81. Okay, so okay, 8.8101 times 10 power negative 13 joule. Okay, the question, the pattern almost like this only lah. Just call you to find the mass defect. After that, find the energy. Just now got extra 1 mega electron volt. Okay, so no questions. So I can stop here. So you can do your Google form.
Thank you,
Okay.
teacher.
Okay, bye.